This is from chapter 10. We're starting with section 2, conic sections, an introduction to conic sections, and mainly we're going to be talking about parabolas today. A conic section quite literally comes from the idea of taking a two-dimensional plane and slicing through one or two cones. You can see these cones are tip to tip, and depending on the angle of your plane and whether or not it slices through one of the cones or two, you get these different types of conic sections. The first one is a parabola. And the second one, when you're slicing perpendicular to the way the cones are oriented, you get a circle, then an ellipse, and then if you slice through both of them, you get what is called a hyperbola. We're going to graph and write equations of parabolas. Every parabola has the property that any point on it is equidistant from a point called the focus and a line called the directrix. So the directrix is this line right here, obviously. It is on the side of the parabola that the parabola is not opening towards. In other words, the parabola never crosses the directrix. And then the focus is always inside the parabola, kind of cupped inside of there. The vertex will lie halfway between the focus and the directrix. And in fact, any point on our parabola will be equidistant to the axis of symmetry and to the directrix. So why do we need parabolas? Well, some of the reasons why we use them are in flashlights and headlights. Parabolic microphones, also I'm sure you've seen antenna that have a curved interior. Solar ovens is another example. With a wider parabola, you can see that the focus is farther away from the vertex, which also means the directrix is going to be further away because the directrix and the focus are equidistant to the vertex. With a narrower parabola, the focus is closer. Parent parabolas. Parent parabolas are parabolas that have their vertex at the origin. The parent parabola that we've mostly looked at has been the y equals x squared. It has the vertex at the origin, and it opens up. Y equals negative x squared also has the vertex at the origin, but it opens down due to the leading negative coefficient. X equals y squared and x equals negative y squared are not functions. They would not pass the vertical line test, but they can be graphed. X equals y squared is going to be a parabola that opens sideways. This one in particular opens to the right. For x equals a negative y squared, of course, we're going to get an open to the left because that is where the negative x's are, just like for y equals negative x squared, the negative y's are below the x-axis. Parabolas can open up, down, left, or right. The standard form of the equation of a parabola with a vertex at 0, 0 is the following. X squared equals 4py would have a focus at 0p. That would be the point for it. The directrix would be y equals negative p, so we always want the directrix and the focus to be on opposite sides of the vertex, so they must have opposite signs. And then the axis of symmetry would be vertical, or x equals 0. The axis of symmetry is a line that cuts your parabola in half. And basically, if you were to fold a parabola over on the axis of symmetry, the two sides would sit right on top of each other. So if the vertex is at 0, 0, then the axis of symmetry is going to be x equals 0, which is a vertical line for an x squared function, or a y equals 0, for which is a horizontal line for a y squared function. For the y squared equals 4px, you have a focus of p0. Notice that the coordinates have switched from the x squared version, and then it's x equals negative p. We can change the equation if we want to move the vertex away from the origin. HK in these equations are where our vertex is. So if you have the equation x minus h squared, that means this is an x squared function, so it opens up or down, equals 4p times y minus k. Then your focus is at hk plus p, because the vertex is hk. And so you would add p to get the focus to the y coordinate for an x squared function, and then you would add the p to the x coordinate if it's a y squared function. And then your directrix can be found for an x squared, y equals k minus p, and for y squared, x equals h minus p. Identify the focus and directrix of the parabola given by x equals negative 1/6 times y squared and draw the parabola. So first off, the parabola opens. Well, which way would this parabola open? It would open left because it's a y squared with a negative coefficient. Okay, so we want to isolate y squared. That just means that we are going to multiply both sides of our equation by the negative 6. That is the reciprocal of the negative 1/6. So when we isolate our equation for this second part, we get that y squared is equal to negative 6x. The next thing we'd like to do is to solve for p. So based on our equation model down here, we have y squared equals 4px, and our equation is y squared equals negative 6x. That means 4p must be equal to negative 6, or p is equal to negative 6/4, which reduces to negative 3/2. That means that our focus is negative 3/2, 0. It means our directrix is x equals negative 3/2, so that's x equals just positive 3/2. And our axis of symmetry is horizontal, it's a y equals 0. We already said this is a y squared parabola, it opens left, and its vertex is at the origin. Therefore, the axis of symmetry to go directly through the middle of it would have to be y equals 0. So all that's left now is for us to draw our parabola with all of our key features. So I'm going to start with knowing where my vertex is, which I know it's at 0, 0. I know that my focus is at negative 3/2, 0, so I'm going to graph that. I know that my directrix line is x equals negative 3/2. When we have an x equals negative 3/2, that means it's a line vertical at a positive 3/2. And of course, that means the parabola is opening away from this value. And just sketching our parabola without making a table of values, it would draw and be something like that. So the focus is always interior to the parabola so that we can make those flashlights work. And then our directrix is on that opposite side. Identify the focus and directrix of the parabola given by x equals negative 1/6 y squared. Oh, my mistake. We already did that one. Identify the focus and directrix of the parabola given by y equals negative 1/2 x squared and draw the parabola. Now in this case, we are looking at an x squared form of the parabola with a negative coefficient, so we know it's going to open up. We want to go ahead and solve our equation for x squared so that it can be in the form of 4py. So that means we've got x squared. We multiply both sides by the reciprocal of -1/2, which is going to be -2. So x squared equals -2y. So that means that 4p is equal to -2. That means p is equal to -2/4, which reduces to -1/2. So our focus is at 0, -1/2. Our directrix is going to be y equals a -1/2, so that's y equals 1/2. And then, of course, our vertical axis of symmetry is going to be x equals 0 because we are still with a parabola that opens at the origin. Excuse me, with vertex at the origin. So we know this parabola is going to open down, but let's go ahead and graph our focus, 0, 1/2. We know our vertex is at 0, 0. Our directrix is y equals 1/2, which is a horizontal line. And so our parabola is going to be a little more narrow this time, of course, since the directrix and the focus are a little bit closer to it. Identify the vertex, focus, and directrix of the parabola given by x plus 1 quantity squared equals -2 times the quantity y minus 1, and we are going to draw the parabola. So for this one, we are not located at the origin. Our vertex is at a different spot because we have our hk to deal with. So if we're looking for our vertex, we are going to take the numbers that are in the parentheses with our x and y terms. And then, of course, it's going to be opposite sign since they're both inside the parentheses. So our vertex is actually -1, 1. That's our hk value. Our focus, since it's hk plus p, then we're going to need to solve for our p value. So it appears we have a -2 multiplied by our 1. So that means that 4p is going to be equal to -2. That's in the same spot up here. So we get p equals -2/4 or -1/2. So for our focus, we have the same h value, so -1. And then it's going to be 1 plus a -1/2, which is a +1/2. So we have our vertex, we have our focus, and then our directrix is y equals k minus p. Had a little recording difficulty there. So in this format, I'm not sure where it cut out, we have 4p in the same spot as -2. So we set 4p equal to -2 to solve for our p value. We get p equals -2/4 or -1/2, which means our focus is h, comma, k plus p, since this is an x squared function. So we have h being -1, k is 1, but when we add -1/2 to it, we get a +1/2. So that's where our focus is. For our directrix line, we do y equals k minus p. In that case, we get y equals 3/4. So we've got our vertex graphed at -1, 1. We've got our focus graphed at -1, 1/2. Our directrix is graphed at y equals 3/2. And then we have a parabola that opens down and is going to be a little bit more narrow because of how close the directrix and focus are. Identify the vertex, focus, and directrix of the parabola given by y minus 2 quantity squared equals 12 times quantity x minus 1, and draw the parabola. So this one is a y squared. It's going to open left, right, not up, down. The number in our 4p spot is positive, so it's actually going to open to the right. We figure out what our p value is by setting 4p equal to 12, and we get that p equals 3. Our vertex in this case is going to be 1, 2. Remember, the h value is with your x and the k value is with your y. Since our focus is h plus pk, our focus is going to be 1 plus 3, which is 4. And then our k value is still 2. And then our directrix line is going to be h minus p, so that it's on the other side of the vertex. So our h value is 1, p value is, what did we get? 3 for our p value. And so we get x equals negative 2 for our directrix. So our vertical line at negative 2, we have a vertex at 1, 2. We have a focus at 4, 2. And you'll notice the focus and the directrix are a little further away from the vertex than on previous examples. So this one's going to open up a little wider. Of course, we can find out how wide if we want to use a table of values to graph actual points. But this gives us an idea of what it's doing. Write an equation of a parabola that has a vertex at 0, 0 and has a directrix at y equals negative 2. So if the vertex is at 0, 0, and the directrix is y equals negative 2, y equals negative 2 is a horizontal line. So it means that the parabola opens up or down. If the parabola opens up or down, it is an x squared value. So the form of a parabola whose vertex is at the origin is going to be x squared equals 4py. We know that our directrix is always y equals, well, at least for the horizontal ones, is going to be y equals k minus p. And in this case, they're saying y equals negative 2. Our k value is, again, our vertex k value, which in this case is 0, 0. So it means we have 0 minus p, and that gives us negative 2. If that's the case, then that means that y equals negative p, and y also equals negative 2, therefore p equals 2. So when we're going to write our equation, we know that we're going to be writing from this one up here, x squared equals 4 times p, which is 2, times y. So we get x squared equals 8y. That is our equation. Our vertex is 0, 0. Our focus, of course, is just going to be 0, 2. Because our directrix is negative 2, so it has to be on the opposite side of that. Same distance away. So if we have y equals negative 2 as our directrix, then we have to have a 0, 2 for our focus. Not super close together, so when we open this up, it shouldn't be super narrow, and it ends up looking something like that. Write an equation of a parabola that has a vertex 3, negative 2, and has a focus y, negative 2. So I just wanted to have an idea of this. So let's see, 2, 4, 6, 8. And so that means that 2, negative 2. Our vertex is at 3 and negative 2. Maybe I'll use a different color. The focus is at 7, negative 2. Which means this thing opens to the right, right? So if the vertex and the focus are on the same horizontal line, then this has to be a y squared type of equation. The vertex and the focus are 4 units apart on the x-axis, which means the directrix should be 4 units to the left of the vertex. So if the vertex is at 3, -2, then of course our directrix is going to be at -1, x equals -1. So this thing has to open to the right. I don't know exactly how narrow it is or anything like that, but because it opens to the right, since we knew our focus and our vertex were on the same horizontal line, that means we're in the form y minus k squared equals 4p times x minus h. Our focus in this format we know is h plus p, k. Our directrix we know is going to be x equals h minus p, because this is a y squared version. And since we know that our focus is at h plus pk, and we also know our focus is 7, -2, then that means that h plus p equals 7. We know that h is 3, and therefore p must be 4. So based on our vertex and now our p-value, we should be in good shape to write our equation from the standard form. So y minus k. So that's going to be y minus a -2 squared equals 4 times p, which is also 4, times x minus 3. So let's clean this up a little bit. We've got y plus 2 quantity squared equals 16 times x minus 3. And that is the equation given the vertex and the focus. That is it for this lesson.